So hi everyone, welcome to my YouTube channel. In this video I am going to explain you about the thermal conductivity by searl's method. In this experiment we require the apparatus this is searl's apparatus, you can see, and these are the 4 thermometers, and to measure the diameter of this copper rod we have to use the vernier caliper, and to supply the steam we have to use the heater, and we have to connect using the tubes to supply the steam across this apparatus. And here we need the beaker to collect the water from these 2 points. So I will explain procedure. So here in this apparatus you can see there are 4 holes. So we have to insert here 4 thermometers. So across these 2 terminals we have to put the 2 thermometers, and here this is to supply the cold water. With the help of tubes we can supply the cold water, and another end we have to connect it the tube, so the water should flow from this end. So this is for cold water connection, and here is the connection for to supply the steam. Okay, so here we are not supposed to supply the within this experimental kit. There will be a heating chamber should be provided, but here we only have this apparatus, so I am explaining you with this apparatus. So once we supply, so here we have to connect the tube, so from the heater, so that steam should pass through this hole, and this is the copper rod. So here we have to keep the 2 thermometers, and here the cold water is going to flow. Because of the flow of the steam across this rod, the water is going to be heated. So the cold water get heated due to the supply of steam across this rod. So we have to collect the water from this terminal in the beaker. So then we have to note down the mass of the water collected. So I am going to insert these 4 thermometers in these 4 holes. 2 thermometers here and 2 thermometers here for the cold water connection. So once you start the experiment, you should insert the thermometers like this. So here you should not keep it open, you should close this box. Okay, and here you should connect the tube to supply the steam from the heater, and you have to connect here the tube to supply cold water, and here you should connect the tube to collect the water that is going to be supplied here. So here like this you have to make the setup, and after supplying the steam you should note down the temperature across these 2 thermometers, and also once you supply the cold water simultaneously you should note down the temperature of these 2 thermometers. So this is the diagram for searl's method to find out the thermal conductivity of a given material, and you should note down the observation here. So distance between the 2 holes, here you should note down the distance between these 2 holes, around it is 10 centimeter, and diameter of the rod. So you should calculate the diameter of the rod using vernier caliper. Here is the vernier caliper. So you should measure the diameter of this rod using vernier caliper. Then radius of the rod you can calculate d by 2. Area of cross section, if you find out the radius you can find out the area of cross section of the given copper rod by r square, you can calculate. And here is the tabular column. So first you should write down steady final reading of the thermometers. So as we know, we are using 4 thermometers. So we have to note down the steady final reading of the thermometers. So you should note down the mark of the mercury inside the thermometer. So here how much you will get, you should note down. So here they have written for all these temperatures T1, T2, T3, T4. So here T1 they got around 100 degrees Celsius, T2 98 and 97, T4. So this is for 1 minute. You should note down the reading of the temperature for 1 minute 60 seconds. So then mass of water collected for T second. So for 1 minute how much water you are going to collect in the beaker, you should take the mass of the collected water, then milliliter, okay, 54 they got for 1 minute, and 4 temperatures you should note down. So repeat the same procedure for other 2 trials. Note down the temperature across 4 thermometer, and for 1 minute how much water you have collected in the beaker you should note down. So in the last column, mass of water collected for 1 second if you want to calculate, divide 54 by 60 second, you will get around nearly 1 gram, you can say 0.9. So here is the formula to calculate thermal conductivity of a given material, that is K is equal to M into T4 minus T3 into D, that is distance between the holes, and area of cross-sectional area of the copper rod, T1 minus T2, temperature across other 2 thermometers. Once you put in this equation, then you can calculate thermal conductivity. So you have taken 3 readings, you should calculate K1, K2, K3 and take the average of 3 readings. You will get the final thermal conductivity of a given material. So at the end you can write the result, thermal conductivity of a given material, nothing but here we are using copper rod. So K is equal to minus 0.744. And the unit of thermal conductivity is meter per second per centimeter square per unit of temperature.